Good morning, everybody. Thanks for joining this session. I'm Dave Jones with Storm Center Communications, the co-chair of the Disaster Lifecycle Cluster. So this event is put on by the Disaster Lifecycle Cluster, and Karen Moe is co-chair. So Karen, please.
Yes, welcome everyone, and we're really looking forward to getting your insights as we pursue our continued efforts to both discover and help our end user community, the applications, to trust these data products, especially our environmental earth observing products. So that's going to be our key focus today. Dave, I think, do you want to, well,
Sure. Yeah, you give a little overview of what we're going to be doing in this session.
Yeah.
The first thing, this session is all about California burning, putting data to work. As everyone knows, California was basically on fire for the entire year, at least some part of California. And while there aren't a lot of wildfires burning right now, there's an atmospheric river hitting the state. And that's really putting a big burden on those burn scars. Lots of mud flows and debris flows are happening. As a matter of fact, our first speaker, who's the Chief Information, Geospatial Information Officer for the state of California, Isaac Cabrera, had to pull out at the last moment because of being tasked to support some emergency response activities with data. So we found someone really quickly to step in his role to talk about California burning and what's going on, and that's me. So I'm going to talk a little bit about the support that we gave to the state of California with our real-time collaboration environment. But first, I just wanted to point out as well, in California, we've had a number of things going on. And so I'm going to switch over to GeoCollaborate here just for a second to show you what's going on. This is California. And what you see is, I'm going to zoom out just a little bit here. Salinas, California, which is right down in here. And I'm going to zoom right into Salinas. And you see these burn.
Do you want to share your screen? We're looking at it in your little micro video.
Yeah, I don't know if the video comes up. Yeah, I can certainly share my screen, Sam.
Or in your upper right corner, if you go to view.
Oh, okay. Yeah, I could just view you larger. Yeah, I'll view you as the speaker.
Full screen for you.
Okay.
Yeah, I'll do view as speaker. Thanks.
Okay, awesome. So, so I just wanted to dive in to show you where Salinas, California is. And what you see outlined here is the river fire complex that is out. It's a burn scar now. But what you see here is a USGS product for the probability of mud and debris flows. And so as we dive in here, it looks like this area in red, which is, if I click on it, says it's a high probability of debris flows given rainfall. There's a farm located in this area where a debris flow came through, and I can show you what that looks like here, just full on the video. You can see this farm here in Salinas where the mud flow came through, broke through some fences, did some damage to a road, and went down that road and into some other areas as well that really washed out some residences, and they're doing evacuations in many areas at the foothills of where these steep slopes are. And if I go back to GeoCollaborate here, there's a lot of steep slope here in Salinas. And that's just one burn scar where they're really getting hit hard from all the rain. Look at all the other burn scars, and USGS has products for debris flow probabilities. So not only when a wildfire happens in California is California in big trouble because of the threat of wildfires and smoke and all that stuff, but once the wildfire goes out, you have a tremendous vulnerability to heavy rains, and it doesn't even have to be that heavy, really. The flood criteria for the Weather Service changes dramatically when you have burn scars because the hydrophobicity changes of the soil, and so when you have rain, it kind of drains much faster. It's almost like raining on concrete in some form or fashion. So in this session, we're going to have a number of speakers. I'll kick it off with a little bit of talk about how we supported the California Civil Air Patrol and the California National Guard fighting a particular wildfire. Then we're going to have Ravon from NOAA is going to talk about her smoke model. That's a very important model that Ravon's been developing for a long time, and it's great news. Had been running in an experimental mode, but now it's running in an operational mode at NOAA, which means it gets a lot more attention and it stays up and operating, so that data can be put to use. And then we're going to hear from Sam Batsley from the University of Wisconsin, from SIMS. And Sam's been doing some great work. Sam and I work together under a jointly funded project under NOAA. It's the JPSS program under their river ice and flooding and their fire and smoke initiatives. Sam is working to use satellite data to rapidly identify like fire perimeters and burn scars. So really looking forward to that. And then Maggie Glasgow from NASA JPL in Pasadena, California, is going to talk about what NASA is doing in their projects to address things that involve California burning, California floods, and things like that. Because NASA, from a research perspective, funds projects that have real promise in perhaps moving into the operational area. So Maggie will talk about that. But what we really enjoy, Karen and I, about this session is the interactivity that we hope to have. And we're going to do a poll first, and I'm going to let Karen describe that in just a second. Then we're going to go into the presentations. And then we're going to break everybody up into groups and put you into these rooms so you can talk about what you heard from these presentations. What did you consider something new and innovative that you took away from it? And what do you think could be done with that information that you just consumed from the presentations? Is there a way forward? And anything goes. Any ideas that you have are totally usable. And then at the end of this session, what Karen and I are going to do is ask you for takeaways. What are the takeaways that you're taking away from this session that you can put into the Google chat or the Google Doc that's up in Kiko Chat? I think starting, I forgot what page it is, but we want takeaways that we can use as priorities for the disaster lifecycle cluster over the next 6 months. So we can then report and talk more about what we accomplished with your help and your input. So that's what's really important here, is that you listen to the presentations, you come up with your own ideas. Hey, this could be applied here, or this could be applied over here. Hey, why don't you do this? Why don't you bring in this cluster and talk about this? All these ideas we'd love to generate. So Karen, I think I'll pause with my comments here and just ask you to talk about the poll that we want to ask everybody to answer.
Yes, so I would like to encourage people to go to the notes session and sign in. And as you're doing that, to really think about what trusted data means. What are some of the key features that kind of come to the top of your head when somebody says, hey, how am I going to trust your data? And if you would move to the Slido at the top of the Kiko chat room. And if you select on the Slido, you should get our question there for a live poll. And Xian, our ESIP fellow, is helping. But let's see.
They also copy and paste the Slido link in the chat box. So you can, I already got 3 people answered. I can share my screen.
Yes, that would be.
Okay.
Yep. So we'll take a minute or two to take a look at what.
Can you see it?
Yes.
Yes.
Yeah, that looks great. I see the word cloud building.
Yes. Yeah. In your, I think I can see.
And this exercise is really to help us understand, because we talk a lot about trusted data in the disaster lifecycle cluster. What does that mean to you? You know, when you think about that. These are some great answers coming in. Thanks for participating in this. See, this is already helping us to think about the clusters we want to work with, like data quality and others. This is great. Keep them coming. 27 responses. All right. We'll let it go for another minute or so.
Yeah. So I think I just mentioned that as you're thinking of those terms, our goals today are really to look at how can coordination and data sharing accelerate our public-private situational awareness and decision-making in support of hazards, especially given the effects of climate. And I think our new administration is going to be focusing a lot. I've read, all of the federal agencies focusing on climate change and how we can be more resilient and responsive. So how can we, within ESIP, accelerate this public and private sharing of situational data, of decision-making data? And we've been focusing on trusted data because that personal trust in the data is a key element for these application users to take up the data. Our second goal is to really help us identify what steps we can recommend to the federal agencies and to our various members so that sharing their data and decision-making capabilities with the application users, with the emergency management personnel, and with the public who are also responding directly to these events. How can we make it easier for our inputs to be meaningful to them? So those are the 2 goals that we have for today. And towards the end, as we go through that exercise of what kinds of recommendations we might want to pursue, what our disasters lifecycle cluster will do is use that information to form our activities over the next 6 months. All right, so I think
That sounds great. All right. Well, while everybody finishes that and thinking up your words, I think what I'm going to do is I'm going to share my screen so we can get into some of the presentations here. So let me pull up. Now there is a presentation mode in. I know I can share my screen, but let's see.
the spotlight.
No, not the spotlight. I wanted to show my slides from the Google Drive just to show you the speakers and then where we're going to go. But I had a,
There
I
it
wanted
is.
to, there, you can see it okay now?
Very good, yes.
Okay, great. So in the agenda, one of the things that we're going to do after the speakers, we're going to have this what, so what, now what session. And maybe you have done this already within ESIP because that's a kind of a similar theme throughout a lot of the sessions. But we're going to ask you to fill out a table in the Google Doc where something that stands out and is important and some things for you to integrate so we can get those points to work on. And what we're just trying to get to here is this creating this ESIP ecosystem of innovation. And what I mean by this is that we have a lot of clusters within ESIP, and the clusters are doing all great work. And like any organization, a lot of that great work is happening in those clusters. And so we're really trying to cross-pollinate those clusters. So for example, if there's something in the discovery cluster that they have that might help us find data faster, we can take that widget or that capability in the disaster lifecycle cluster and connect with agencies and organizations that are actually that we're working with operationally. These are organizations that are actually using GeoCollaborate to access data and share it across their organization or into other decision-making environments. So it now opens up a pathway for us to take some innovation within ESIP, the drone cluster, community resilience cluster, put that in and expose these agencies, organizations, and users to what's going on within ESIP, and then provide the feedback that's required back into those clusters so they can refine either their processes, refine their approaches, maybe take a different approach totally, maybe build upon what they're doing. So this ecosystem of innovation is something that we can really put to use. And I think we've been kind of doing it already within ESIP. It's just now kind of putting it on a slide that kind of makes it exciting and makes it come to life. And so so before we get into the speakers, I just wanted to share this quote. We've talked about trusted data. You've put in your inputs, and this comes from a book by Michael Mann called The New Climate War: The Fight to Take Back Our Planet. And it's about credibility and integrity. It says credibility and integrity are a scientist's bread and butter and greatest asset. It's the currency that allows scientists to serve as trusted communicators to the public. So when we lose trust communicating science, that's just about everything a scientist has. And so we need to really focus on building that trust back, putting trust into operations, and putting it into the data that we curate and the data that we offer, the data that we discover. Because as data discovery becomes easier, more and more decision makers are going to be finding that data. Well, if they can't understand how to use that data, if they can't understand what it means, if it's not clearly communicated, then there's going to be a trust breakdown. And you might be doing the best effort possible to make sure that data is accurate, but if you cannot communicate it, partner with somebody who can communicate it correctly and present it to them in such a way that you build that trust. So this was a really good quote. And so we had you enter the information into Slido. How do you define trusted data? if you, if that poll, Sean, is that poll still active?
Yes, I can make it active.
Okay, so if you just keep it active for just a little bit longer and somebody comes up with an idea while they're seeing a presentation, they can still go back to that poll and enter some more keywords, which will be great. And so, so we're going to move on into our first talk. We did have scheduled Isaac Cabrera, the California Geospatial Information Officer, and he had to pull out because of operational tasking because of the floods and the catastrophes they're experiencing. That's just the only way to say it in California. Before I start to give my presentation, I wanted to ask Karen if there was anything that we missed in the beginning. Was there anything that we need to say before we jump into the presentations, just to make everybody aware of what else is going to happen?
Just one other quick point, and that is that as you listen to these remarks during our talks, we'll have a little opportunity after each talk for a question and answer for clarification and the like. But please be thinking about ideas that kind of stand out for you. And if you were to integrate this information into your work, what else would you need? What kinds of things would you like an answer for? And any other thoughts or notes that you have about what you're hearing with these different talks. Please, have a piece of paper available or an area for you to take some notes, because that kind of information, I think, will contribute to the breakout discussions as we get into a little more detail there.
That sounds great, Karen. Yeah, that's a good point. I appreciate that, and I feel kind of like empowered for this session. As a matter of fact, I lift up a little bit. I have on my ESIP shirt, and the only thing I didn't get to is making ESIP shaped cookies, so I could have them ready for this session. But I'm going to dive into this first presentation, which kind of might help you put your arms around some of the data sets that were available and were used during California wildfires. As I mentioned before, both Sam Batsley and I are funded by NOAA under their Fire and Smoke initiative to put more data to work serving decision makers. And what I'm going to talk about here is how we were called and asked if we could provide the HER smoke model data and help the California Civil Air Patrol respond to task orders for imaging from the California National Guard. So what you're seeing in this picture here is the August fire complex that was burning. It was a large one of the largest in California's history. And you see these red boxes. These red boxes denote FAA flight restrictions. So these are areas where the FAA had temporary flight restrictions, TFRs, and they put them around these fires, and they do this in real time. What this means is that no aircraft can fly in this area unless they're above 12,500 feet. So this also impacts the Civil Air Patrol when they're trying to image these yellow dots. These yellow dots are task orders from the California National Guard for damage assessment imagery. So the Civil Air Patrol gets those task orders. Typically, it's a file that they look at on their computer, but they had no way of merging that information in with any other relevant data, so they could really make good decisions. And so now you can see the temporary flight restrictions. You can see the yellow boxes, which are the task order imaging task orders that the National Guard needs. And on top of this, it's or underneath, it's tough to see, but this is the burn scar for this fire. You can see the burn scar. That's updated every 24 hours by the Forest Service in a real-time geospatial database. And then the colorful image that you see on top of that is the HER smoke model, the high resolution rapid refresh smoke model that Ravon is going to be talking about next. And so essentially what you see here, what's going on is the wind had shifted from west to east was blowing the smoke to the east and opened up some patches of areas where the Civil Air Patrol could fly over and image for damage assessment purposes. And so this is one of the first times they've ever had an integrated look at this critical data that's coming from multiple agencies. So you have the HER smoke model coming from NOAA. You have the FAA flight restrictions coming from the FAA. You have the task orders coming from the California National Guard. That's a sort of quasi-federal state organization. And then you have the burn scar or the burn fire perimeter data coming from the Forest Service, all together. And so let me just show you what happened very quickly. This happened in a 2-day period. The Civil Air Patrol, Captain Mark Wheeler, sent an email to NOAA at Ezril, which went to Ravan, and they said, can we get her smoke model? We need it for our decision making. Ravan sends an email to the JPSS program and includes both Sam and myself in this email saying, can you guys contact or get the HER smoke model over to the Civil Air Patrol in California? And so on the email started on the 22nd. By the 25th, we had stood up GeoCollaborate as an instance, and we were actually training the California Civil Air Patrol in 2 days how to use GeoCollaborate to access the HER smoke model, because Sam at the University of Wisconsin was producing the HER smoke model in a geospatial form and format that made it easy to access. GeoCollaborate is designed to access REST services, KMLs, all that sort of stuff. So we were able to tap into that. We had been doing it previously anyway. And then the only challenge we had to do is schedule a telecon time with this California Civil Air Patrol to train them on what they could do. And so that all came together very quickly and was very successful. So just from a 30,000-foot standpoint, this is what was happening. The California National Guard, as a trusted data source, is producing these task order image locations that they need for rapid damage assessment. So think of that as an internet source for information. The California Civil Air Patrol on different systems was accessing this through using GeoCollaborate, was updating in real time. And as the HER smoke model updated, that updated in real Earth and then also updated in GeoCollaborate as a collaborative common operating picture. So while a bunch of other devices and emergency operations centers could have accessed this data as well to put it up on their monitors, they actually use these devices here to access them from their respective locations so they could coordinate on when to take off, swoop in, and take those pictures. So I'm going to end my talk here, just sort of setting that stage, because I'd like for Ravan to speak, and then Sam is going to talk about a new capability that he's been innovating on to identify these burn scars. And I did put in the chat this address for YouTube, not in the chat, I'm sorry, I can put it in the chat, but it's in the Google Doc for you to watch later about how a little bit more information about the California response. So with that, I'm going to introduce Ravan Ahmedov from NOAA, from Ezril, the Environmental Science Research Laboratory in Boulder, Colorado. And Ravan, I'd like you to take over, and I'll just say next, and I'll advance the slides for you. So thanks so much for taking the time to join us for this session today.
Yeah, perfect. Just a second. So, yeah, please let me know if you hear me well. So thanks, Dave, for the introduction. I'm going to briefly describe the operational. Since December last year, this model, high resolution rapid refresh smoke model, is operational at NOAA NCEP. The operation means that no outages in the model simulations. And this is the model. the forecasting system is maintained by NCEP, which is the operational branch of NOAA. And here I show this 3D or volume visualization of smoke. And you can see this big anticyclone over the western US, and the smoke is just wrapping around it. And you remember what was going on last summer. And Dave also gave one of the examples. And you can see this big smoke plume over California. Next slide. So what does HER mean or stand for? It is high resolution rapid refresh model coupled with smoke. And this model has been operational at NOAA for weather forecasting. And now the model includes smoke forecasting capability, also smoke weather interactions. I will show one example. So how we forecast the smoke distribution in the atmosphere in such high spatial resolution. In this model, it is for each grid pixel size is 3 by 3 kilometers. So here on this slide, you can see the CONUS domain. We have another domain of Alaska, but the main application of this model is for the CONUS domain. So in real time, we ingest satellite fire radiative power data from 2 VIRS and 2 MODIS satellites. And it is important, I should say, essential for our applications to use the high resolution and also accurate certainties, of course, but detailed fire heat flux detections, so-called fire radiative power data in real time. So by ingesting the data in real time, every hour a new forecast starts, and the forecast length can go up to 48 hours depending on the time of the day. So here you can see the FRP distribution over the US this last September, and again shows those intensive large wildfires across the western US. Next slide, please. So by ingesting the satellite data in real time and estimating the fire emissions, we simulate the smoke distribution, advection, vertical mixing, convective mixing, and many other processes in this weather forecast model. So this is one of our forecast products, which is widely used. It's so-called near-surface smoke, basically smoke which affects health or visibility near surface. And also you can see the 10-meter wind barbs shown on this plot. But there are many different ways of visualizing these products, and Dave, for example, as Dave showed, the GeoCollaborate, also one of the widely used tools. And on our website, you can see the URL in the title. On this website, maintained by our lab, you can find static images displaying the HER smoke forecast products. Next slide, please. Smoke is actually, I should say, probably the most challenging air pollutant to forecast, because a lot of smoke also is emitted into the free troposphere, higher altitudes. And so one of the another widely used products, smoke forecast products, is the vertically integrated smoke. Basically, the mass of smoke in a given in a per square meters, basically how much smoke in the total atmospheric column. And this is also important for aviation and other applications. Next slide, please. And just to highlight how complex is the vertical distribution of smoke, here I show a vertical cross-section in south-north direction. The fire, you can see this little arrow pointing to, is the Mendocino complex fire. Until 2020, this fire, which was burning in 2018, it was the largest wildfire in terms of the burned area in California's history. Next slide, please. And so here I show animation and showing the smoke distribution, also smoke transport. And you can see those darker colors pointing to heavy smoke pollution areas over the state of Washington, Oregon, Northern California. And on the right panel, you can see one of the like snapshots of the PM 2.5 concentration map detected by the AirNow network. And we use the PM 2.5 measurements to evaluate the model, but note that this model is designed to simulate smoke, but there are other pollutants also in the atmosphere. And next slide. One of the applications of HER smoke is to forecast these low visibility events, and during these heavy smoke pollution events in Seattle, for example, the Seattle airport, there were a lot of delays, and so this is again one of the examples of these wildfires and the smoke, how it can affect our daily lives, ground transportation and aviation, and how important it is to get this data in different format, in different usable on visualization products to the users with a short latency. Next slide, please. This is just one example to highlight the high smoke pollution. I picked the city Medford in Oregon, but that city was affected by fires not just in Oregon, also in California. And I think in 2018, probably Medford, because of the size and population, was the hardest hit city in terms of these smoke pollution events in the United States. And next slide, please. Yeah, next slide. Yeah, and this is just one example. Because of time, I won't discuss it much. But HER smoke is also designed to improve weather forecasting, because during dense smoke episodes, the solar radiation reaching the ground is reduced. And just last summer, you all remember those orange skies, those images from California and Oregon, and certainly in these cases, air temperatures are also reduced, so weather doesn't get as hot as expected during afternoon hours. So the HER smoke is the first operation weather forecast model in the US, and at this resolution, maybe in the world, which includes these interactive areas of feedback, the smoke feedback on meteorology, on radiation. Next slide, please. Yeah, this is my last slide. So Another application of her smoke is, as I said, visibility, but also the solar energy production. As here I show two her smoke predictions for incoming direct radiation, basically radiation that we can measure near the ground, this shortwave radiation coming from the sun, and this direct radiation. So you can see the stark differences between these two forecasts, because one doesn't include any smoke impact, but the plot on the right panel includes it, and you can see these huge reductions in the solar energy, which has implications for solar energy production and visibility. So I stop here, and I'm happy to take questions. Thank you.
Ravon, thanks very much. I'm going to just take a look in the chat window here to see if we have any questions for Ravon. Let's see. I don't see any. Are there any questions, Karen, that you see in any of the other areas where people can ask questions? We do have a couple minutes.
Not at this time. Although I have one question. I just wondered myself, does the model with the smoke flow give a prediction about where fires might be coming next? Does the smoke?
No, Karen. So the fires in the model all are based on the satellite detections. So like a future fires or a given fire, how it will spread, that's another area. And so-called fire behavior models can do that to some degree, but those are like localized models for running at very, very high resolutions. Yeah, so no, the model just the satellite detected fires.
Very good, thanks.
Ravon, I have a question for you, and I'm wondering, whoops, let me switch that over there. Is there a difference between smoke and air quality?
Yeah, Dave, so when we say air quality, it includes many different variables. There's actually also a definition of air quality forecast, for example, for ozone, for PM2.5. So I would say certainly smoke is a part of this air quality phenomenon, but air quality is a much broader process and problem. It involves, again, secondary pollutants like ozone, which this model does not forecast.
So there are components. So if you wanted to do an air quality forecast, her smoke model, if there were fires around, could be a component to help that, but not really the total answer.
Yes, and one of the challenges is to do full atmospheric chemistry to include it in such a detailed model like her. That requires a lot of computational resources, and that's still in works. There are models, but of course resolutions like CMAC and other models.
Okay, well, that sounds great. Thanks, Ravon. I appreciate that. If you can stick around, that would be awesome as people think about questions. And I'd like to move over to Sam Batsley, and I'm going to stop my video. I will share my screen and introduce Sam. So let me go here. So hopefully you can see the screen there. Sam, is that right? I'm going to put it into play mode.
Yep, that looks good.
Okay, did that go full screen for you?
Yeah, I think it's a little do. Thank you.
Okay, great. Thank you, Sam. It's all yours.
All right, so I'm following up on Ravon. One of the projects I'm working on is how to detect the fire scars or burn scars with JPSS satellites, which are NOAA Joint Polar Satellite System. to provide preliminary burn intensity estimates to National Weather Service for debris flow hazard assessments. So that's kind of a complicated title. If you hit the next slide, I simplified it to say, go ahead, next slide. Providing faster satellite-derived input maps for mudslide forecasters. So essentially, there's a problem of delay, and I'll get into that as we go. Next. So the basic situation is that debris flows after fires, or debris flows after fires, either way. It's a statement, or it could be nouns or verbs. But what happens, as Dave alluded to earlier, is that you have a destabilization of the soil when the fire removes that vegetation, and it actually converts some of the soil to clay and ash in such a way that it becomes water repellent, and so you end up with a case where the whole side of a slope can just go, like, you know, an avalanche, and that's what we're talking about. So next slide. And this is what it looks like. This is an actual photograph. It almost looks like a model, but this is Mendocino, California on July 7th, 2018. And this was more lives were lost in the mudslide than in the fire. They fortunately did get an evacuation order out early enough to save most everybody, but there were, you can even see a helicopter hovering right in the middle of this scene over the top, looking for people that need help. Next slide. So this is where the evacuation orders were. Those are the orange area and the burn scar you can see above in the hills. And so what we're really worried about is getting that information to the emergency managers, the EOC, the Emergency Operations Center, and the IMET, or the incident meteorologists, so that they can look at the situation and say, oh, we have a rain setting up. You know, the real problem is when you have rain, moderate to heavy rain, over an area that is steep terrain and has been burned. So there's a bunch of factors in there. If it's a flat prairie, it's not necessarily going to threaten anybody if it rains on the burn scar. But if it's slopes that are steep and the burn is severe, and there's people downstream of it, that's where the concern is. Next slide. And so I'm going to use an example here of the Williams Flats fire in Washington that occurred in August of 2019, pretty much a month-long fire. Next slide. And there is a really sort of the gold standard approach for defining and identifying and measuring burn scars is called the normalized burn ratio, and it produces what's called a BARC map, which is a burned area reflectance classification. It's a fairly simple algorithm of near infrared and shortwave infrared that are sensors that are on many of our land remote sensing satellites, like Landsat and VIIRS on NOAA 20 and SUMI NPP. And so this is kind of what's happening. This is sort of the status quo. This is Landsat imagery being used to produce a burn scar or an estimate of burn severity. Then a BEAR team goes into the field and validates this, and actually, and then the map gets used for a variety of purposes. Initially, it's for just assessment of the burn for the Forest Service, but it can also be used in emergency management situations. But there has to be a certain serendipity involved, because it takes some time to produce a map like this, especially if you're using satellite input from Landsat, which has a 16-day repeat cycle. So next, it's BAER for BEAR. just as responding to the chat question, but I'll get into that a little bit more in a moment. So the alternative method, which is what we're working on with data from 2 different satellites, from VIIR's sensor as opposed to the OLI sensor. The VIIR sensor is on NOAA 20 and SUMI NPP, which are current two different satellites that are in synchronous orbit, sun synchronous orbit, polar. And the advantage of doing an NDVI difference is that NDVI is already produced operationally, so you don't have to construct it. And so you essentially just do a difference. And so we're producing what's called a burn intensity delta greenness estimation. It's much more coarse. It's a 375 meter pixel as opposed to the 30 meter pixel you get from Landsat. But you can get it almost every day as opposed to every 16 days. So there's this fundamental trade-off between timeliness and spatial resolution. And essentially what we're trying to do is apply something that was really never intended to be used for emergency management to emergency management. Next slide. And this is where the advantage happens, is in terms of swath width, essentially. So this is an example of a daily acquisition for Landsat OLI. It does about 15 orbits that cover the Earth, and it repeats every 16 days. And so this is 1 day's worth of collection, and it just collects over land, which is why you see gaps. And the next slide. This is a single pass of SUMI NPP or NOAA 20. And they are 50 minutes apart, so you get an extra width on this if you combine the two, but it has a 3,000 kilometer swath width instead of 185. So clearly you get a better opportunity to see the same piece of land more frequently. You just, with these optical sensors, you're subject to cloud cover, so you can't always know that you're going to see the land or see the ground. And so frequent acquisitions are a real key for timeliness. Next. So this is how a bark map is made. The fire creates a burn scar. It's observed by the satellite. It gets processed. Bark map is made. It gets validated with a BEAR team, which Dave put in the chat, which is a team of folks that go into the field and actually do samples on the ground and spot check the imagery that they have and see what and assess the severity, because there's a difference between intensity of fire and severity of burn, and it depends on the materials and whether the place is burned more recently or it's never burned, or and then they feed that into a GIS model, and the weather forecasters use that model output to decide whether and that mixes with the weather forecast, and you end up with a warning. So it's a complicated workflow, but you can see on the bottom here, I show that the green dots are the actual, or squares are acquisitions. So there was, for the Williams Flats fire here, you see that they had an acquisition before the fire on August 23rd that was clear enough that you could actually see the ground. And then the next acquisition was September 8th, but it was completely cloudy. And it wasn't until October 10th that they actually had another clear image in order to do the difference burn ratio to figure out what parts had burned more severely than other parts. Next slide. So the alternative technique, which produces the bridge map, the one that we're working on here at the Space Science and Engineering Center and the Cooperative Institute for Meteorological Satellite Studies at UW-Madison, is to take the acquisition opportunities that we get from SUMI NPP and NOAA 20, which you can see the blue squares are acquisitions, that come every 2 or 3 days for each satellite. And in combination, you get pretty much daily coverage. Sometimes the edge effect is a little, if your site isn't squarely in the middle third of the scene, it can be, you can get some angular distortion. So it's not as, the pixels aren't quite as crisp, but you can, generally, if you combine these two satellites, you're getting way more chances. And in this case, there was a clear scene on August 27th. So we had that initial August 7th or 8th image. The Landsat image was August 7th. It didn't get a new one until October 10th. And then here we got, on the 27th, we got a good scene. So going to the next slide, we'll compare them. So the Landsat BARC map, 30-meter resolution, is the top two images. The bottom two images is the VIIRS bridge map. The one on the top, you can see is higher resolution on the upper left corner there with a 30-meter resolution. And then the output is the erosion potential on the right. And you can see the orange areas are the ones to be concerned about. And then comparing that with the VIIRS input to the modeling, and then the output of the model for severity, you can see it's fairly similar. It's not that much different. There's a little bit different. It tends to overestimate in the middle of the severity rating, but the high levels are quite similar. And it's 44 days earlier. So this is a successful example. It doesn't always work out this nicely, and we're trying to establish that to figure out which what are the elements that influence the accuracy of this. And so essentially what we're trading off here is spatial resolution for time, but it looks like in the model output, we're not actually losing that much. And so if you can save 44 days, you can at least now know where to worry, what parts to focus on, So, next slide. Here it is again. This is, I think if you just toggle back and forth between this slide and the next slide, yeah, you can see the difference. So they match up pretty well. And the conclusion is BARC maps are more accurate, bridge maps are more timely. Bridge maps may appear to be good enough for the kind of application that the National Weather Service is concerned about, which is, let's get that warning out there. Let's know what we should be worrying about before while we're waiting for the higher resolution BARC map to materialize, which, next slide, it does eventually, but not always. Sometimes it's too late. We need to do some more case studies. We want to continue efforts to automate this process. We've developed a web dashboard that collects the before and after imagery. We're utilizing direct broadcast for the after imagery, which means we get the imagery directly off the satellite as soon as the overpass happens, using the direct broadcast network, as opposed to waiting for it to go to a national archive and then become available to us. And yeah, that's the conclusion. I have a lot of things to say about this and the process, but I think I'll leave it here for now and we can talk about it later. Thank you.
Sam, thanks very much. That was some great information. And I'm looking in the we have about 30 minutes to go. So I want to get to Maggie. So remember, we're going to go into breakout sessions after Maggie. So take in what you heard Ravon say and Sam say, so you can add that information and ideas for how we can move forward in the document during the breakout session. So without further ado, I'd like to go to Maggie Glasgow from NASA JPL there she is. Hello, Maggie. And I'm going to work on getting your presentation up. So if you could please just introduce yourself a little bit more, I'll get right on your presentation.
Sure. Hi, everyone. I'm Maggie Glasgow, and I am representing the NASA Disasters Program today. And I'm going to give you a little introduction to what NASA did in response to the California fires. I'd like to also give credit to my co-leads on this this fire response. I was the lead coordinator on this, but Abby Naston was my co-lead, and John Paul Vernier was the atmospheric lead on this. So if we can go to the next slide. So we were activated for this event for over 3 months, and we still have post-fire assessment ongoing. But as you can see, we did have a number of observations that were taken using different satellite and airborne instruments. The National Guard did engage us to request that we take UAV SAR observations over the fire to help to identify the burn perimeter and burns eventual burn scars. So we engaged with them very early on, and we contacted our California stakeholders very early on within the first 5 days, and started sending products to them within the first 10 days. We had air quality management districts engaged, and eventually we're also engaged with the state of Washington and Oregon. Next slide, please. So as you can see, we have a NASA GIS mapping portal where we have posted our products, and we have over 18 products that were generated and posted to this portal. And I have posted here the URL for the product gallery that has all of the different products that were generated. And since my slides will be available, I'm assuming after this presentation, I'll assume that you'll be able to have access to this URL. But here's just a quick snapshot of some of the different products to the left here. Now there was another, several snapshots below this, but this just gives you an idea of how many products we did produce for this specific event. And it ranged from satellite observations to the UAV SAR airborne observations. So we used MISR, we used ASTER, we used UAV SAR, AVRIS, also an airborne instrument, SMAP, the International Space Station, Calypso, VIIRS, MODIS, and we also had a number of modeling products that were generating smoke plume information as well. Next slide, please. So who were we engaged with? So we had a number of California stakeholders. As I mentioned before, we worked with the California National Guard, who engaged us very early on and requested that we fly UAV SAR over a number of the fire complexes. So we gathered information for them and shared that information with them. We also worked with the California Geological Survey. We worked with Isaac Cabrera, the California State Geographic Information Officer, who was unable to join us today, unfortunately. We worked with Cal OES, Cal Fire, and two of the air quality management districts up in the Bay Area and down in South Coast. And we also worked with FEMA Region 9. And we did work with the USGS and are currently working with the USGS in the post-fire assessment realm with trying to do debris flows and burn scar assessment. So Dave asked me to talk about what kind of feedback we got. And we, of course, got a lot of feedback from the National Guard with our colleague Phil Balin, who also works with the Disaster Lifecycle Cluster. And so he told us that this really helped with awareness building for the different products that we had generated. They were presented to the Joint Operations Center, to the Intel disaster awareness and management groups. It was really good to have links to the individual layers with metadata and links to the portal site. But we need a distro list to help notify them as soon as possible about the availability of products. And we need to develop more emergency manager friendly products. And there is a need for more training on the use of products. And we'd like to do that in between events so that we're not doing that during the actual response. Next slide, please. So I'm just going to go really quickly through some of the products. These are more JPL centric since I kind of stole this from a JPL presentation. But so we produced what's called a damage proxy map from the UAV SAR flights. These are maps that show where potential damage has occurred. So these are the flight lines of the UAV SAR instrument that flew over this fire complex and the resulting damage proxy map that was produced. So NASA Disasters Program provided funding to support the flights. And Andrea Donnellan also provided a shortwave infrared camera to fly with UAV SAR. And the first science flight to fly over a complex occurred on September 3rd. Next slide, please. Now, we also use Miser to map the plume heights, and we were able to do a 3D rendition of the plume heights on the actual portal. So if you go to the portal, you can look at this, and it shows the Miser plume heights in 3D. And so we have a number of heights available for different days. And so the plume heights show where smoke, transport, local air quality, and can validate the plume rise models. So that was some interesting information that we were able to provide on the portal. Next slide, please. And last but not least, I believe this is the last data slide. The Aster instrument was tasked for this particular event, and they were able to get information on where burn scars were located, and they covered various burns areas, and the information on the various fires was provided in GIS ready format by our science team at JPL. And so the visible near infrared and thermal infrared wavelengths allow features such as the smoke and heat of the fires to be identified and mapped. Next slide, please. So just to summarize, there is the California Fires event page on the Disasters Program website, and that's the URL there. And then there's the mapping portal gallery of the California fires, which the URL is included there. And if you have any questions, then of course myself, Abby, or Jean-Paul would be happy to answer them. And that is it for me. Thank you so much.
Thanks, Maggie. That was terrific. Boy, what great presentations. We're getting a lot of chatter about how great the presentations were. So this is terrific. Well, it's time for breakout sessions. Here's what's going to happen. The speakers are going to go in one room, so you don't get to contaminate what people are talking about by talking about your presentations even further. So we're going to break up into groups, and I encourage you to refer to the Google Doc. And Karen, if there's any other thing that we should add before we go into the breakout sessions, let me know. We're really just looking for your what you consumed, and then what you think the what, so what, and now what's that you can put in. So
Yeah.
is there anything else, Karen?
Yeah, just a real quick, we're definitely looking for guidance from this group to say what we should pay attention to over the next few meetings before the summer session. And that we will only have, about not quite 10 minutes to do this. Yeah.
So the breakout rooms are going to go fairly quickly. So try to get your discussions going and what you thought you liked and you want to put down in the thing. Remember what breakout room you're in, because you can scroll down on the document. I think it starts about page 4 in the Google Doc, and start typing in some of your answers. So thanks, and we'll see you in about 10 minutes.
Super.
Hey, Susan, so you're sort of thinking that we will stay here in the main room just in case people get lost or need help?
Yeah, and I'm muted. Yeah, I'm going to stay here in the main room. When it was longer, I was going to join a group, but I just had to do a little rearranging. It seemed like everybody but one person in room 5 dropped off, so I didn't want to leave that person stranded. But if you want to join a conversation, actually, there's no reason for you to have to stay here. You want me to throw you in a conversation?
I can probably, it looks like I can pick one.
Go for it.
Taking a look at
That'll
the folks
probably be
in
more
there.
fun than hanging out in a quiet room with me.
Yeah. Let me see. So I guess one thing that I was a little bit worried about, did everybody know where to go to get the slides to take notes on before they sent them off?
Yeah, I think they did. Usually there's at least, I mean, the groups are pretty big. There's at least 5 in each room. So
Yeah. Okay.
one of those 5 will know where to go. Yeah, I was messaging with Dave. I was like, okay, we're losing time. We're losing time.
Yeah.
I'm like,
That's
okay,
kind of,
we just went from 20 minutes to 15 to 10.
yeah, 10's barely enough.
Yeah, exactly.
Yeah. All right.
Well, go enjoy a conversation.
All right. I will see you back shortly.
Okay. Jensen, how are you?
Hey, how are you going?
We are, they are in breakout groups and we'll be coming back to the main room in about 3 minutes. Do you want me to throw you into a breakout group?
Yeah.
Sure, I will do that right now. Did it pop up? Ravon, I'm putting you back in the speakers room. Hi, Don. We've got everybody in breakout groups for another 2 minutes. Would you like me to throw you into a breakout group? I can't hear you, so I will give you that option if that's something you would like to do.
Here we are. We're all coming back. Welcome back from your cluster group. So hopefully there were some good conversations.
Time flies.
Awesome. So so the nice thing about breaking up into groups, and I was in a group with the speakers, just thanking them for taking the time and talking about how ESIP works and all that sort of stuff. And Sam let me know that he actually did attend a ESIP meeting in New Hampshire in 2000 or 2001, early 2000s. So Sam, welcome back. We'll have to reteach you the secret handshake.
Yeah, it's like a new organization. It's great.
So this is awesome. So Karen, I'm going to see if you can take it from here for the next few minutes, and we can take a look at what was entered.
Yeah. Do you want, are you, you want to see what these, the Slido document?
Yeah,
like?
yeah, that's right.
Can you pop that up?
Yes.
And while you're doing that, I only managed, it went really fast, but I was in room 3 and there was a clear focus on how to communicate the information from predictive models. And that I thought that from the disaster life cycle, our group, that I think it would be beneficial for us, or at least for myself, to be better informed about, what are the guidelines for officially for communicating information to the public. But when you get to the area of models that say you may be in danger from smoke or debris fields, that there needs to be very specific ways that can be captured. Would anybody in some of the other groups want to capture make a statement about maybe a key thing that came out, like in group 1 or?
Hi, Karen. Yeah, I can go. I was in group 1. We talked about kind of the great work that was done and then maybe what some of the next steps might be. We kind of keyed on synthetic aperture radar as a way to maybe create finer scale burn scars, and kind of building from that, maybe thinking about what the data product needs are so that those could inform the mission and the data providers for those upcoming SARS missions that are coming up. And then we also talked about integrating people into it, like, are there people on the ground, and might they be able to provide some information either between the fire and when debris flow might happen, or around the fire boundaries. And we talked about the ethics of that, and that it would be complicated to do, but just as an idea, kind of moving forward, some ideas there.
Yeah, an important chunk to chew on. future discussions. All right, how about in group 2? All right.
We're not sure. Were we in group 2, Rupta and Peng? I'm not sure what group we were in.
Nancy, I think we were in group 2. Do you want to share?
Well, I'll just say a couple things, and then I think you should start too. Yeah. Let's see. I think we came up with a couple of, not necessarily in responses to the questions, and we haven't written them down yet, but we thought that the connection with community resilience is really important, not only for making the connections between the local community and the scientists who are creating the data, that maybe, and this was my point, and Rupa, you may want to put your own in there, just that if it'd be nice to have a way to connect those local communities who sometimes, don't have the trust because they don't know the science, or they don't know who the scientists are, and their communication is going through, the local law enforcement and that sort of thing. Those sorts of folks, and so they don't necessarily see the results that those people, their liaisons are basing their activities or their work on. So a connection between that line of communication might be really important to work on.
Definitely an area we might collaborate on. Yes. Oh, great point.
And Rupo, I don't know if there's anything else.
Yeah, very quickly, I think the point we were trying to make is that there need to be systems in place to create pathways, to be able to share data, to be able to create relationships between the groups who need this data most and the community that's creating the data. The quote from Michael Mann basically spurred my question, because it's all about credibility. So how do you do that beyond just the scientific community with end users?
Yeah, especially when there's distrust historically.
Absolutely.
Great point. Yeah. So how about, was there group 4?
Hi, Hi, yeah, it's Lorraine. Well, we chatted a lot. We were in awe of the ability of so many different agencies and groups and stakeholders to come together quickly and then create output products that were being used, that were almost in operational format. So I think that was a powerful flow through and theme that was in all three talks, being able to serve up, models that were assisting. And could assist in an operational format.
Yeah, good point. They were excellent talks.
That's great. We will probably, Susan, you might be able to chime in here for us. Are we going to get slapped if we go a few minutes over?
Well, everyone asked for longer breaks last year, so we did build in an hour break. No, nothing will automatically close if any of you would like to stay and continue your conversation for a little bit.
Well, because I would like to get the Slido input back for next steps. So we're going to keep this document open here. So if you want to put more information in, but I would like to, if I could, and we can continue the conversation certainly during the coffee break too. We can all like kind of move over into one of those little tables and make it a follow-up kind of conversation. But I'd like to have you click on the Slido link, and Sean, our community fellow, is pulling up the next poll, and I'd love for you to put in what are your key takeaways from this session. What is it? I agree that putting data into operations quickly and getting feedback, all that sort of. What are your key takeaways that we can take as the disaster lifecycle cluster and move forward with? Because we have a disaster lifecycle cluster meeting in 1 week. We meet every Thursday, the first Thursday of every month at 4 p.m. Eastern time. And we want you to come join us so we can expand the disaster lifecycle cluster and we can really get some things going. So please put information into this poll so we can get that. These are sort of our marching orders for the next several months. And it's awesome. We really appreciate you guys sticking around for this whole session. I'll be joining probably the coffee break too, if anybody wants to chat. And I just want to give our speakers a thank you again. If anybody can, wants to put in their clap and, thumbs up sort of symbols for the speakers. I really appreciate your time. Karen, is there anything else you'd like to say?
I think you wrapped it up very well. Thank you. Yeah, excellent talks.
That's great. And keep putting in your key takeaways. I see 4 people have come in, but please put in some more. And we appreciate you. Thank you for coming to this session, and hope you enjoy the rest of ESIP.
Bye for now.